Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with part 2 of our talk about noise. We're going to talk today about receivers and some of the things that you can do about noise. I hope you find this helpful. So let's just dive into the charts where we left off in episode 290 and continue on talking about noise. All right, we're looking about what we can do about noise in this second part here. Let's talk a little bit about receivers. The theoretical minimum discernible signal at room temperature is limited by thermal noise. Now, it happens at HF, and you have to trust the ARRL for this number. It's minus 174 dB compared to a microwatt. So we're actually talking about power here per hertz. So to get an MDS for a mode, you have to multiply, or you can add in dB, the bandwidth. For example, CW, if you use a 500 hertz filter, you're letting in a total noise power of minus 147 dBm. Now understand that's minuscule. It's really, really tiny, but it is noise. Now, the noise figure of a receiver is the output of noise generated by the receiver itself to the theoretical MDS. For example, a very, very good low noise amplifier will have a noise figure of 2 dB. So instead of that CW at 500 hertz at minus 147 dBm, your minimum discernible signal will be minus 145. Okay, so you've lost 2 dB. So if there was a signal that was just barely hearable in the noise, it won't be now that you've gone through that LNA. Well, HF radios have horrible noise figures. I calculated the noise figure for my Tentec Jupiter at 13 dB. 13 dB. So instead of minus 147, it'd be minus 134 dB, which is, the thing is adding that much noise. Okay. Now the manual claimed 11 dB, but I believe the 13 dB. But this is typical for an HF receiver because the noise floor is well above that point anyway, so it doesn't matter. Now, this is something that's important. As a rule of thumb, a very good rule of thumb, all of a receiver's noise figure comes from the first amplifier, the very first amplifier that the signal hits. Now, there's a corollary to that. If you have preamps in your system, they can sometimes help, but just remember that they add noise. You will probably be better off not using the preamp. Now, at HF, the band noise floor is well above this thermal noise floor here. Say maybe 10 or 12 meters, which are very quiet bands. And this might be a good place to throw in that preamp to make a soft signal stronger. Now, at VHF and above, when doing weak signal work, a low noise input amplifier is very important because that's going to set the noise figure for everything that follows. Because all amplifiers add a tiny amount of noise. But the thing is, that's important when you've got a tiny amount of signal. So if you've got a tiny signal and tiny noise, you add the two together and multiply that, now it's not so weak. So the next amplifier is seeing a stronger signal and then adds a tiny amount of noise. Not going to make any difference. You go further down the chain and you're dealing with volts instead of microvolts. And the microvolt that amplifier adds in noise just isn't going to make any difference. Now, I might point out on the ICOM IC7300, which is our reference station, and on the 7610, which is the same, that there are two preamps, and the second preamp is designed specifically to be a low noise preamp. So you might keep that in mind as you use that. I just want to show this kind of how this looks like. This noise floor right here, as I was taking this picture, the entire noise floor would go up and down together with static crashes. The static crashes affected the entire band. This is 40 meters. You can see down here CW and FT8, and then it's fairly active with the single sideband signals here. And you can see that there's so much energy on the FT8 bands that it sticks way up above the noise floor there. Some of these others are kind of down, see? Not terribly far, 10 dB maybe above. 10 dB above the noise floor will give you a fairly good signal. Now, I want to talk about grounding. Proper grounding of both stations, antennas, and coax can be a major factor in reducing noise. And I want to show you some drawings and a photograph from my Astave number 8, which is a video on grounding. Just to throw in a little bit of an aside here, several loggies were after me to purchase the My antennas in Fed 80 through 10 meter antenna. So I did. I took channel funds and went to myantennas.com and ordered that antenna, and it should be here before too long. And I'll do a video, at least a video on it. I looked on My Antennas. They had some articles about some technical subjects, and one of them was on grounding. Well, I'm always curious to learn about grounding, so I went to that page, and lo and behold, it consisted of my Astave number 8 on grounding. It says, if you want to learn about grounding, watch this video. I was quite flattered, of course, but I don't think that's the last word on grounding by any means. But and yes, they did it right. It was embedded. They hadn't stolen it. It was embedded properly, according to YouTube rules and all that. Anyway, that's what happened. One thing to think about antennas, as the wind blows across them, it creates static electricity. That has to find a place to get to ground. Okay, I once blew out the front end of a radio, not paying heed to this. I had an antenna, and I had the lead, the coax, going right into the little handheld radio, an IC7H or something like that. And it blew out the front end because I had no path for that static to get to ground. The static was so much, there was so much charge on the input of that it blew out the front end. I had to send it back for repair. And so make sure that there is a DC path to ground, or at least a resistive path to ground that it can get to ground. A ground in your operating station should look something like this. A ground rod right outside your station. In my case, I've got a crawl space, so my ground lead goes down and then out. So I don't have anything direct to the outside, it goes to the ground. Now here is an example of something that actually happened to me. I had rehabilitated a vertical, the HF9V, and it had some buried bare radials, which gave it an excellent ground. Plus I had a whole bunch of insulated radials on the surface. I thought this is going to be one fantastic antenna. So I ran the coax about 100 feet to the radio and got incredible amounts of noise. The antenna was unusable because of the noise. It was just unbelievable. So I grounded the cable braid near the ground rod here. So this cable here was grounded on both ends, and then this came up the inside of the radio, and oh my goodness, what a difference. An amazing difference between the two. So grounding, you should take all your incoming coaxes, ground them to the ground rod with a lightning arrestor, and then take it inside to wherever you are, even if you're on the second floor. Inside your station, you should have a single point ground. In my case, it's about a 1 foot piece of 3/4 inch copper pipe. and everything in the station is grounded to that, and then that is grounded down to the ground rod outside. I won't go into grounding, otherwise I'd be repeating the video. But this is what my ground rod used to look like when I had just 4 lightning arresters. I now have 6. And I've got a couple antennas I can't bring in because I don't have a spot for them on the grounding plate here that's on the ground rod. This, by the way, this copper here that is turning green where it's been exposed, it's hose clamped to the ground rod, is the wire that goes up to my single point ground in the station. Another way that you can help with noise is antenna placement. Try to get the antenna away from noise sources. If you have a bit of land, move the antenna away from the house. The noise reduction is worth the tiny loss from the extra coax. Try directional antennas such as loops and Yagis. You can put the noise source into the null of the antenna. Mag loops really work well for this. Sometimes, not all the time, but a transformer balun or a choke balun can reduce the pickup by the coax shield. Combine that with grounding those at the lightning rod, and it can really help. Tuned antennas, such as mag loops, which are very high Q, even dipoles, which are single band, can reject out of band noise and just concentrate on the signals that are in band. Now, a way to locate household noise sources. The easiest way is to run your HF radio on a battery. Turn off all the circuit breakers and then turn them on one by one. When you find the offender, find whatever on that circuit is the offender. Often ferrite beads on the power cords can help. Your enemy with noise from the house is conducted emissions coming out the power cable. It is harder, of course, to find intermittent noise sources this way. Some of the odder noise sources to look for include GFI outlets, including GFI breakers. Okay, they'll sometimes have, oddly enough, some electronics in them. Touch lamps, of course, and anything with a power cube. Check the garage too, as well as motion-sensitive lights. Now, there are neighborhood noise sources. One way to find them is to use a portable AM radio, which are getting a little hard to find, but a portable AM radio, and walk the neighborhood. They may have grow lights. Now, I realize that in some areas of the country, people are allowed to grow their own marijuana, and so these are legal installations there. And so this is a great chance to use your diplomatic skills to put some ferrite beads on those grow lights and so on. I mean, technically they're responsible not to radiate, but in practicality, they're just going to thumb their noises at you if you try to force the issue. Okay, and of course look for power line noise sources while you're at it. Now we come to the part where it's important that you learn your receiver. Modern radios have a truly amazing assortment of features that will make separating signal from the noise much more possible. Now, read the manual. Study the manual. Sit at your radio with the manual. Try every interference fighting feature in the manual. Try it. Actually put it into practice. The third bullet refers back to the second bullet there. Note that some radios come with 2 manuals. For example, the IC7300 has a basic manual, which is printed, and a full manual. I would recommend that you print the full manual. You can have Office Depot or Staples print the manual from the CD that comes with your radio, or from a downloaded file that you have. Print the manual double-sided and in color, and then have it spiral bound with plastic covers to protect the papers from getting torn off. It is worth the cost to have that full manual and then sit down with your radio and go through that silly thing page by page and learn the features of your radio that will help you to reduce interference. Modern receivers have many features. They help reduce fundamental overload with roughing filters, attenuators, if it still gets through anyway. The attenuator puts the radio signal in a more linear part of the receiver's transfer function and can help reduce interference that's nearby. Automatic gain control, actually. Try slow, medium, and fast. You're going to find slow or maybe medium with single sideband, medium probably with CW, occasionally fast. Fast is so fast that you don't know that it's even happening. Another thing you can do, and a too much unused technique, when you're talking to somebody with a strong signal, turn down not the audio frequency gain, but the radio frequency gain. If you'll turn down that on strong signals, the background noise melts away. It's like magic. Of course, radio's like magic. Other ways of reducing interference with your signal are passband tuning. That was actually invented by Collins back in the time of the 75A4 receiver. I've got one of those in the basement, and it has passband tuning on it. The idea is to move the IF around without actually moving the signal. Now, the way that does that, that can cut out part of the interfering signal. The IC7300 has two, or they call it twin, passband tuning, one for the low end and one for the high end. Of course, it doesn't do it at IF because it's a fully digital DSP. You can also look at the bandwidth control. These days, these have brick wall filters. A signal is either in or out of the bandwidth. There's no in between. You've got choices of wide, middle, and narrow filters with steep skirts, wider skirts, all kinds of things. Try the different ones and find out what works. For example, if you're listening with a 3 kilohertz bandwidth to a single sideband signal and somebody is up the band and creating a lot of very high-pitched noise, you can actually narrow the bandwidth. It makes your signal a little bit more muffled, but you can actually completely eliminate that interfering signal. So it's a trade-off between the two. I do mention the notch. There's both automatic and manual. Use the manual notch on CW because the auto notch thinks CW is a carrier, which it is, and it eliminates it. There's also passband shaping on Yaesu radios, some Yaesu radios, which allows you to actually change the shape of the response curve and can reduce parts that are noisy while still getting some of the signal through. Now, I've often said there are only a few items in physics that are magic. One of them is quantum mechanics. But another one is digital noise reduction. Digital noise reduction works by looking for coherent signals and dumping the rest. If you've ever in your mathematics done an autocorrelation function, you know what I'm talking about. If you don't, just think that it works by magic, which it does. Who was it that said that the most advanced technology civilization has to offer is indistinguishable from magic? Somebody in the comments will tell me who said that. Sometimes digital noise reduction will distort the intended signal. So you have to decide what your threshold of pain is. Usually DNR can be adjusted in a menu, or sometimes there's a button for it. And you want to pick the amount that will give you something that you can understand. It will distort the signal slightly, but man, it can make a lot of that noise go away. Now, it eliminates uncorrelated noise. A correlated signal, speech is a correlated signal, and so DNR will not take away another speech waveform, like an interfering speech waveform. It can take away static crashes to some degree. It can take away all different kinds of noise. But if it's a speech waveform, it's correlated, it's coherent. So you, like any other interference fighting feature, take a look at it. I leave DNR on all the time for single sideband and CW. A CW signal, by the way, is coherent, so it will come through the DNR just fine. I leave it on all the time, and I'm pretty aggressive in the amount of DNR that I have on. But remember to turn off DNR for digital. Let the software in the computer do the work, because what may appear to the filter to be uncorrelated and therefore noise and thrown out might be the way the digital mode works. And the digital mode will pick out what it wants and throw away the rest. So on digital modes, turn off everything. You can even turn off the AGC if you can, but turn off noise blanking, turn off notches, turn off filtering waveforms and so on. Just turn off DNR and just let the signal go on through to the computer. Now, I want to talk just a little bit about modes. Different modes resist noise differently. Now, single sideband and AM have no inherent noise control. The waveform is analog. You're modulating the size of the radio signal, and static and everything else just looks like another AM waveform. So it will be inherently difficult to pick out when you've got those problems. Of course, DNR can help quite a bit. Now, FM has noise control to a point, and then it will be overwhelmed by the noise. But an FM receiver picks the strongest signal. RTTY is actually a frequency mode. It is frequency shifted. It's between two tones. It has no noise control built into it. There are only 5 slots in the character field in Baudot, in the Baudot-Murray code. And most of those 32 slots are used. And so any bit error is going to give you an erroneous character because it will interpret it as some other character. Now, FT8, which is also an FM mode, it's modulated between 8 different tones, has extensive forward error correction and is nearly error-free. In fact, most of what is sent is the error correction mechanism. That's why it comes through so well and can come through actually if the signal is below the noise. PSK31 is a phase modulated mode, and that's somewhat similar to FM, and so it has a little inherent noise control. It's much better than RTTY at getting through in a noisy channel. Olivia is an example of another mode that is like PSK31 that has outstanding forward error correction. It trades time for accuracy. It takes a long time to send. It's freeform text, unlike FT8. It's freeform text and comes through very, very clearly. Pactor, which is still sees some use, includes both forward error correction, meaning that it puts a bunch of bits in there, and if you get something that's gunked up, you can pick out what it should have been. And ARQ is automatic repeat request. And that is, if it can't figure out what the thing was, it was so garbled, it asks for a repeat. Now, Pactor, the way it works, the old Pactor 1, it would send a packet, you'd get a knack back, no good. It would send it again, get a knack back, no good, send it again. Okay, now this time it's got 3 packets. It'll compare these and try to correlate them, and can sometimes reconstruct a proper packet from those, and then it will just send an acknowledgement and we'll go on. Now, I have to admit, CW noise control, CW is an AM mode. It's either on or off, so it's the height of the signal that makes the difference. The noise control for CW is largely in the head of the receiving operator. But I will tell you, I have played with some of the CW receive features on the 7100 with my FTDX 3000, and they're amazing. So you ought to take a look at them. So in summary, this summarizes the 2 videos. Noise is everywhere. High amounts of local noise can be very frustrating. So try different modes such as FT8 or JS8 call, which is like FT8, but a little more free form. Use your receiver to its maximum potential. You've got a lot of stuff in there, and I'll bet if you crawl through your owner's manual, you will either learn new stuff or review stuff that you learned but had forgotten about. Boat anchors don't have this. They just don't have all these features, which is interesting, as the bands were much more crowded back when the boat anchors were having their heyday. And then I will conclude simply with one word, my favorite word in ham radio, as in life: persevere. Well, that wraps up our discussion of noise here in episode 291. This is a 2-part episode, 290 and 291. And at the very end of the video, there'll be a link back to the other section if you want to review that again. Please take a look at dcasler.com/support for all the different ways that you can support this channel. By the way, a number of people have asked for a list of the Ask Dave videos, because I talk about Ask Dave, 250 or something like that. It'd be nice to have a place you can go and just find that video. Go to dcasler.com/previous. That's just the one word, previous. dcasler.com/previous will give you that list of all the Ask Dave videos, and we'll try and keep that up to date. So, until we next meet, 73.